Okay, I'm just going to go through a few more examples on series circuits. So let's do this one. So when you see a schematic or a circuit diagram, okay, and it's got a voltage that looks like this, what that means is they're measuring the voltage across this resistor. Okay, I think there was some confusion on this in class last week, and I'm going to be sure and talk about this tomorrow or this week. But this doesn't mean the voltage from the battery. Okay, they've given you that separately. And if they're going to give you the voltage of the battery, it's going to be V total, and it's going to be at this battery symbol location. Each of these resistors is using some voltage from that battery. Okay, and this 40 volts is just telling us this R2 guy here is using 40 volts. Only him. Okay, that's not the voltage for this guy. And obviously, that's not the voltage from the total because we see they've given us that, and that's a different number. Okay, this is like taking a voltmeter. So when we took the meters and we measured the batteries, we put the little clips or leads on either end of the battery. That's what they're doing here. Somebody's taken a meter and they've measured from one side of this resistor to the other, and they're getting a 40 volt value. I'm going to try and do that this week in class with some better meters that we have access to so you can see that. Okay. But in the case of this problem, our givens, okay, we're given a resistance for R1 of 20 ohms, so we can put that here. So we've been given a voltage for R2. Okay, this is not a resistance. We don't know that yet, but we know that this guy has a voltage of 40 going across him. So we can put that in his line. Okay, this is all my values related to R2 go in this line. Okay. And then our total for our battery is 120 volts. So those are all the things that we're given. Okay. Again, reminding ourselves of our rules, we see that we've got enough information here to get the voltage across the first guy because we know that these two have got to add up to 120. That's one of our rules. Okay, all our components have voltages that add up and they equal what's coming from the battery. So this has got to be 80 because 80 plus 40 is 120. Now that gives me a way to get the current for this line because I can use Ohm's law. I can divide voltage by resistance and solve for current. So if I divide 80 by 20, I get 4. And then again, going back to my rules, I know that my current's the same for the whole circuit. So I can go ahead and fill in 4 there and also there. And then I can get my final values, again, going back to Ohm's law. So I'm gonna divide, I want resistance, so I'm gonna divide voltage by current here. Okay. So divide 40 by 4, that gives me 10. If I divide 120 by 4, that gives me 30. Also, these add up to 30. Okay, so I've got my two voltages adding up, my current's all the same, my two resistances are adding up. And then if I wanted to throw power in there, I would just multiply current and voltage. So 320, 160, and then I can add those up. I get 480, or that's also what I'd get if I multiplied 120 times 4. Okay. So this is just another piece of data. Okay, it's another information piece for this resistor. You're not always going to get resistance for both resistors. Okay. Let's see. Let me do another one. That one's really similar, so I'm going to pick one that looks a little different. Let's look at this one. This one, they're giving us a voltage for R1, and then they're giving us a voltage and a resistance for R2, and nothing pertaining to the battery itself, but we'll be able to figure that out. Okay. So we're going to fill in what we know. We know that R1 has 10 volts. So I'm going to put that under the voltage for R1's line. I know that R2 has a voltage of 20 and a resistance of 10. Okay. And that's what I know so far, but I know I can use my rules. My voltage adds up. Okay, so I've already got V1 and V2. I can add those. That gives me 30. I've also got enough information in this line to get current because I've got voltage, I've got resistance. If I divide voltage by resistance, so divide voltage by resistance, that gives me current. So 20 divided by 10 is 2. Using my rules again, all my currents are the same. And then using Ohm's law again, I'm going to divide those, get a resistance of 5. I can divide here. I could also add. Okay, so double checking, my voltages add up, my currents are all the same, my resistances add up. Ohm's law, 2 times 5 is 10, 2 times 10 is 20, 2 times 15 is 30. Power, last thing, just going to multiply these two together. So 20, 40, and then 60. Also, these add up to 60. Okay. So as long as you've got a few pieces of data, you can use your rules, you can use Ohm's law to get the rest. Okay. I think I can do one more in the time I have for this video. So let me do this last one. Okay. So givens, R1, I have a voltage of 20 volts. So I'm going to write that in the voltage portion of my R1 line. R2, I have a resistance of 20 ohms. I'm going to write that in resistance. Voltage total from my battery, 60 volts. Going back to rules, my voltages add up. Okay, so I've got 20 plus something has got to equal 60. That means that line is going to be 40. Now I've got two values here. I can use Ohm's law. I can divide voltage by resistance and get current. I'm just going back to this equation again. I told y'all we would use it a lot. So that's going to be 2. 2 and 2. Okay. And then I can use Ohm's law more. All right. So I'm going to have 20 divided by 2 is 10. 60 divided by 2 is 30. These two add up. Okay. They add up to the total. My current's all the same. My voltages add up. So everything looks good. And then my last step would be power. Just going to do voltage times current, 40, 80, and 120. And power adds up. So you can get this final number either by multiplying your total line or you can just add those two. You should get the same number either way. So, okay, so hopefully that helped with some of the series circuit problems. Practice, practice, practice really, really, really does help. I promise you.